Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about rotor, blown wing or tail seater. So let's dive deep into it. Now, what exactly is the dream here? A dream is we want to have a love child of aircraft and helicopter, something like this. Now, the core scientific term is VTOL, aka vertical takeoff and landing. That is our dream, meaning runways are too cumbersome. So we want something that does not need it. That's the science fiction dream. That's what everybody has been dreaming the moment Wright brothers flew. So it's one of those things where a lot of attempts have been made, but almost every attempt had some compromises where it was like, yeah, it can do it, but it's like, it's a crippled stuff. Like it was not very efficient or quiet or things of this nature. So there was always, a penalty of that design. However, the recent conflict of Russia-Ukraine made UAVs priceless again, because before this, UAV, while there were some conflicts, you have to understand, large-scale nation going at each other is not something that happens often. And again, Russia going to boom boom with someone else, that's a very rare thing, or something of that scale. So that did happen, and UAVs went from, oh yeah, it's a good asset, to no, it is the warframe. So things have changed a lot. This was the most disturbing I've seen. It's like, why the heck that soldier was not moving? Like drones are not quiet, especially quadcopters. Like, and it is too slow for like, that sort of, or God forbid they figured out some sort of a noise cancelling system, but, or maybe he was just sleeping or too tired. It's like, this felt so wrong. It's just like, you're just there and like some, almost like ecto brutus, like it's very disturbing. And this is a Shahid drone where Ukraine finally realized that if you have a helicopter and you have a gunner on it, they can generally take it down quite reliably. So at this point in time, UAV industry that people were hoping or claiming it was gonna cap out in few billion, now there are individual UAV companies that are crossing billion-dollar evaluation, multi-billion-dollar evaluation. So the whole field has got renewed interest. Basically, I do have to commend Ukraine for, basically they had this issue and they're like, okay, what if we take Cessna and we just boom, make it spicy and boom. So yeah, they just remote controlled it. It was like so horrifyingly clever that why the heck nobody thought of it? Again, you don't think of these sort of thing if you have like, hey, give me some cover and there is nice fighter jets doing it. It's like, if you don't have those things, then you are like, okay, might as well use the Cessna. Now, let's look into some history of it. Now, VTOL have been attempted many times by every Tom, Dick and Harry. It's not something that, where it's like, oh, it may be good. No, it's a very important thing. Like, okay, isn't helicopter the perfect thing? Well, helicopters are just not good enough. Meaning, if I give you a fixed quantity of fuel, no matter what you will do, a fixed wing aircraft will generally be much faster and more efficient. Not only it will go faster, it will actually save money, meaning your distance covered would be dramatically increased, meaning X amount of fuel, you can go 100 kilometer, or X amount of fuel, you can go 200 kilometer while going faster. So fundamentally, there is no discussion between helicopters or fixed wing, and not to mention helicopters cannot really go very, very fast. So people always been trying to make this happen basically. And as far as we know, tilt rotor aircraft is the best blend we got so far. And V-22 Osprey is one of those successful options that was mass produced. Now be mindful, lot of options have been made, lot of prototypes have been flown, but the fact that you can have like, hey, I want to order these, there are only few, and V-22 Osprey is the few, so to say. So this as of now is 400 plus production in 2025, and again as in use. Now 400, you may not have context for this, but you have to understand from US point of view, 400 is chump change. So this is too low, because again, it had a lot of downfalls. Basically, systems were not polished enough and they had lot of issue, like not little bit of issue, lot of issue. It took too long to optimize it. It's almost coming to its own retirement, so to say. So history, as of now, only tilt rotor works, and one tilt rotor has actually made mass production, as in hundreds of units of those, and even that is not perfect. It still did not get that full coverage that people were hoping for. So history, like people have been trying, like this was the, and you have to understand, planes for Navy are a bit different because they have brutally strong landing gear. Because when you are trying to land on land, you are like, let's feather it, everything nice and easy. It's just like, nice and easy. When you are going on aircraft carrier, you have to understand all things are lol, meaning where is your runway? No, it's not there. It is moving considerably, and it's also swaying on all three axes. So that's your runway. And you are going fast. And here's the deal. To make sure that plane can actually stop, they realize brakes are not fast enough. No reverse thruster is trustworthy. So they have hooks. Basically, there is a hook in the plane and there is a rope, so to say, or cable, catching cable on the deck. You're supposed to catch it. Now, here's the deal. What happens if you miss it? Yeah, that's why the landing gears on aircraft carriers are so brutally strong. Is because they're supposed to go at full force, meaning they're not landing or feathering it. They're going balls to the walls. They're going. The idea is if the catching cable catches you, it will slow you down. Enjoy. If it breaks or you fail to catch it, you should have enough thrust to just go on the other side because there is not enough room to slow down. So that's why the landing gears are brutally strong. Like tons of mass has to be added just on the landing gear. So that's why Navy was working so hard to make this sort of thing. It was a very costly lesson they have learned. So they are always trying to have VTOL. The first people who want VTOL, they are there. It's like, it's expensive. Shut up, take money. Because again, Navy is very hard on aircrafts. Now, tail seater. Now, tail seater, you have to understand, a lot of designs have been attended, like F-35, one variant that does this. Is that if you're not using it during the flight, you might as well not carry it. Like same with this. Basically, if you can take three variants of it, one that is made for aircraft, like, you know, big super carrier as they call it, one of those puppy. Basically, it has enough oomph, enough thrust and all that it can just eat it. That's the second best. Then you have the third worst option, this puppy. This puppy has a giant helicopter blade, so to say, that is spinning. It's a turbojet, but it's powered by the main engine. So you have nozzle going downstairs and then the cap opens up. If you have seen Die Hard 5, Die Hard 5 or something like that, it had a very interesting scene with this. So they have that. Penalty, because you have such a giant volume of useless stuff, once you have actually taken off or once you have slowed down in flight, it's a useless space occupier and also the mass penalty. So it has the worst option, so to say. But again, these are perfectly for Navy. Apparently, Navy is a whole different branch and they are like, hey, we need something that actually touches the enemy and we do not have aircraft carrier on the other. So they are like, okay, for Marine, they do not need range, but they need something that can just like yeet out of there. So, okay, yeet system. Air Force is like, no, give us the best F-35. They're like, tada, landing gear, lightweight. They just trust on mid-air refueling to do long-range mission, but because they have no longer have that giant turbine in the center, it's like free space, missiles, extra fuel. So that's why you never want to have things unless you are using throughout the duration, so to say. Heck, if possible, people will remove landing gear. So if you can remove it, remove it. That's the biggest problem. That is the reason why tail seater are such an important thing. And airstream is a finicky beast, so to say. Airstream is very, so to say, what we call susceptible to drag. Meaning, you must have seen a lot of YouTube video where people are flying a small aircraft and they just put a hand out, plane starts to drift. It's like, why? Well, because again, even that small space, like your human hand, can create enough drag that it will twist a light aircraft. So trust me, you do not want this sort of abomination design where you have like basically a plane, but you are bolting a quadcopter onto it. Can it fly? Of course, it does fly. People are buying it, but it's worst of everything. It's not a full agility quadcopter, nor it's a high efficiency fixed wing. Because again, once you actually try to do forward motion, all the motors and their rotor blades, they will create enough drag where it's like, what's the point of this design actually? So that's why you have to understand Airstream is very twitchy, very twitchy. You want it to be smooth. If it's not smooth, it's not. The best design I've seen so far was this design, non-tail seater one, where they're folding the wing. So once it unfolds it, it's like smooth. It flies very well, all of that. And you have to understand, these sort of systems are limited by the fact that they have a pilot. So pilot, can, like on principle, they can strap down like an astronaut, but they don't prefer that. So even though modern jet aircraft technically has enough power to weight ratio that it can just yeet out of there, but you will not do this. So fundamentally, orientation is limited. However, UAVs no longer have that constraint. That's why tail seaters are making an amazing comeback, because again, miniature of electronics and requirement of UAVs, they makes it super awesome. And tail seater solves all of the issue. It does not have any penalty. It's not like, okay, to do this, we have penalty that is like, you know, giant stuff that we are just losing away. No, there is no penalty of tail seater. So let's look at a real world example, Roadrunner, basically a reusable missile. So this puppy has twin turbojet VTOL and autonomous air vehicle AAV. Basically this is one step ahead of UAV. UAV is unmanned remote control. This puppy has AI. Basically you activate it, you deactivate it. You don't do anything other than that. So yeah, they have reached that level. And the whole point of this missile is you launch it, either it hits its target, job done, go home, it's done. Boom. So job done, they don't have to do anything. But what happens if it misses, or you don't want to boom something, but you want to do surveillance? There's like, okay, do it surveillance. So if it misses, it will go and land. Like it will just pop its leg and it's just like a land. Because again, if you can take off is much harder. Landing is much easier, especially when it's not big enough, heavy enough, where it's like, it just lands. That's not big of issue. And then you can refuel it. That's why they are using jet engines. You can refuel it and go again. So either it hits its target, job done, awesome. It misses its target, no problem, refuel it, go. And you can also do surveillance. So a missile profile has now been expanded. And fundamentally, it can do high subsonic speed. Now let that be very clear. Because it's using jet engine and aerodynamics is sound enough, I could easily see 2-3 generations from now, these could easily touch Mark II. And it has much lower cost. Now, right now, it's in bulk order, not mass production. And all companies are very confident because of the size, because of the simplicity of the design. In principle, they should be able to make it half or 1/3 the cost of a normal Hellfire missile, or maybe even 1/10 of it. Practically, if they start to order 100,000 unit of these, that should be doable. Now, I think the perfect target for this is helicopters, because you have to understand, movies give us this wrong idea that missiles have fuel. Missiles do not have fuel, especially air to air. They just launch and hope they hit. There is nothing more. It's just like, done. 2 seconds, 3 seconds, 3 seconds is also too much. It's like in Fast and Furious, they have a missile that's like, there is no chase. Either it hits you or it misses you. And there is another penalty of, because again, missile is a bigger flying missile. It's like, yeah, we have to have a system where it detects whether it has missed or not. If it missed, it goes push. That's why you see Top Gun is like all the missiles that are missing going boom, boom, boom. Yeah, they have to do that. It's a safety system. So this system does not need to do that safety interlock system. And either it misses it or not. Now, helicopters are a very stuck situation, because again, they are not as fast as fighter jet. So if a missile locks it on, they have to time the flares and countermeasure precisely, so missile runs out of fuel. If they do it too early, missiles are like, oh, I can see you again. It might hit it again. But this puppy is not that fast. It's like, I see you. The helicopter detects it's like something is coming. It's like fires the flares. It's like, whoa, 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 too much noise. AI is like, bro, too much noise. Go up. It's like, now all the flares cool down and all that. It's like, tada, I see you. So I think this will be brutally efficient with helicopters. Like brutal. Like helicopters, no helicopter zone. Fighter jet might be easily able to outrun this, but helicopters, no. This is bad for helicopters. Like no helicopters. So this is one that is active and in use. And then we have Sikorsky. They are also developing this RBW, rotor blown wing. Now, this puppy is from their innovation department. Basically, they have a company, and then that company makes money, and they have a small R&D department. That department is to think of new ways of putting warheads into foreheads. So their department, Sikorsky Innovation, developed this RBW. They do not have an official designation as of now. They did do what we call proof of concept, meaning they have actually built it, actually flown it, and shown like it works. Money started to flow in. This is good. Like, this is not a minor achievement. This is like short uptake money achievement. And they are the primary replacement for all the fixed wing UAV right now. Meaning only things they have to do is like, A, become high speed enough, B, mid-air refueling, done. Like, because it can take off from anywhere, they can take off from aircraft carrier, and they can take off from a truck, so to say. So as long as you can get them anywhere, they can take off, and they can actually land in a remote location safely. So fundamentally, and given the fuel tank, this would be as close in terms of efficiency as a normal Global Hawk, so to say. So payload and range would be preserved, and compared to a helicopter, there is not even a competition. So it's a true air asset, and they are showing in the presentation videos are like, oh, we're gonna carry humanitarian service. I'm like, bro, your company is warhead to forehead, not hearing aid or something like that. It's like, what the hell? They have a hospital. I'm like, bro, it's a missile. Like, you are showcasing, like, oh, they do not want to piss people off. So it's like, okay, we have internal missile bay. Okay, how it is so internal missile bay? health packages. I'm like, that was so cheap. And again, I'm reasonably sure once they actually make the full scale one, they will have the legs folding. So that can be done. This is a next level of evolution with UAVs. They can give you the range, the freedom, flexibility. So fundamentally, any nation who wants to be in the forefront in the next iteration, they have to develop this rotor blown wing technology. Not exactly this exact design, but something like this must be in their arsenal, and cheap enough, mass produced enough where they can actually deploy it, and one or two pieces will not cut it. So this is the next iterations of UAVs, large scale UAVs, not tiny quadcopters one. Although there is one quadcopter that people have figured out, the same company that made that flying missile is like, hey, what if you put a brick on front of it? So super cheap drones, you just brick it. They have done it. So that's there. So these are the rotor blown technologies. Really important, really, true evolution of what we always dreamed of without penalties. Not like, oh, we have to do this, but it has this penalty. No, a full-fledged wings. Although I don't think this is suitable for human, but it is what it is. So this was my presentation on rotor blown wings or tail sitter. Hopefully you have liked it, learned from it. In that case, please click the like button. I hope you have enjoyed it. In that case, please subscribe, press the bell icon if you're free. And if you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Leave a comment because I do try to reply to all of them. Thank you.